Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Qaida binti Muhammad Yusuf and my magic number is CE210046. Okay, I want to explain about question 1a. So the expression is y equal to ax square plus bx. So the manual calculation I get is the answer x square over 2 y double prime minus y prime x plus y equal to 0. So the MATLAB for the symbol is a b x y dy d2y dy dx and d2y dx. So y is ax square plus bx. So dy dx differentiate y and d2y dx differentiate dy dx. So for equation A, I get d2y over 2, and for equation B, get dy minus x d2y. So the last is simplify the y and get the answer dy x minus d2y over 2 x square. So we move to the question B. The equation is y equal to x power of 3 over 2 plus c over x. Is the solution for the differential equation dy over dx equal to 2x square minus y over x. So we need to integrate the factor, and the final answer I get is y equal to x power of 3 over 2x plus c over x. So we move to the MATLAB calculation. The symbol is x, y, and c. So y equal to x power of 3 over 2 plus cx. So differentiate y, and the equation is 2x square minus y over x. So expand the equation, and the answer is 3x square over 2 minus c over x square. Alright, move to the next question. C1. 1 is the method of separation of variable. So we need to integrate, and the answer is y equal to c exponent negative x power of 3 over 3. And for the C2, power series without recurrence relation. So y prime plus x2y equal to 0, and we get y a0 x0 plus a1 x1 plus a2 x2 as a3 x3 plus a4 x4 plus a5 x5 plus a6 x6 and so on. So y prime equal to x equal to negative x square y. So left hand side equal to right hand side, and we get the final answer is a0 exponent negative x power of 3 over 3. So we move to the MATLAB calculation. So the symbol is a0, a1, a2, a3, a4, a5, a6, x, and y. So y we get same as the manual calculation, and y prime we differentiate yx, so dy equal to x square times y, so expand dy and get the answer is a0 exponent negative x power of 3 over 3. So that's all from me. I pass to the next presenter. Thank you.
Assalamualaikum and hello. My name is Shafawati binti Simeon and my matrix number is CE210087. Here I am will be presenting to you the question 2. For question 2a, I have to determine the solution of y double prime minus y prime equals to exponent to x minus x plus sine x using the method of undetermined coefficient. For the first step, we have to find the value of yc, which equals to a plus b exponent x, as it is case 1 where m1 is not equals to m2. For the second step, we have to find the new values of 3 yp's. As for yp1, it is exponent to x over 2, yp2 is x squared over x plus x, and yp3 is 1 over 2 cos x minus 1 over 2 sin x. For the last step, I need to total up the new values that I obtained just now, as y equals to yc plus yp1 plus yp2 plus yp3, and the answer will be a plus b exponent x plus exponent to x over 2 plus x squared over x plus 1 over 2 cos x minus 1 over 2 sin x. As you can see from here, my answer from the manual calculation is proven in my simulation software MATLAB. Here is the new yp1, new value of yp2, the new value of yp3, and the final answer. For question 2b, the solution given in the previous question must be shown by using another method, which is a variation of parameter. For the first step, we have to find the value of a, which is equal to 1, and the fx is exponent to x minus x plus sine x. We can conclude from here that this is case 1, and then we have to find the value of y1, y1 prime, y2, y2 prime. And the new values must be cross-multiplied to find the value of Wronskian, which equals to exponent x. For the fourth step, we have to find the value of u and v. And for the last step, we have to find the value of y, which equals to u y1 plus v y2. And the answer from the manual calculation is proven right through using the MATLAB simulation software. Here is the answer for Wronskian, exponent x, u value, v value, and the final answer. Right now, I will pass the next question to Aisha. Thank you.
Hi, my name is Siti Aisyah Nur Ain binti Syabuddin. My matrix number is CE210080, and today I'm going to present about question number 3 for my group. For question number 3 is about system of the first order linear differential equation. And as shown here is the equation for non-homogeneous system. And this is my manual calculation, and this is my simulation. For my simulation, I'm using Maple to simulate the equation. In simulation, I find the eigenvalue first, and the eigenvalue that I get is as same as manual calculation, but a bit different. In manual, that I multiply the value with 15 so that I can get the read in decimals. And also in simulation, I got the value is in fraction, but I change it to decimal. Then I need to define eigenvectors for V1 and V2. I also got the value for V1 and V2 in fraction, but I change it to decimals. Then the value that I get in simulation also as same as in calculation, manual calculation. Then I put all the value to in terms of general equation of homogeneous system. For question 3b, it needs to determine the particular integral for the non-homogeneous system, which is yp is for non-homogeneous. So here, I get the answer, and the answer from simulation also same as manual calculation. Then this is the yp value. For question 3C, you need to formulate the general solution for the non-homogeneous system by means y equals to yc plus yp. And in this simulation, I use in terms of IH plus IP. Then I get the value, and the value also same as manual calculation. But this is in fraction. But if we change it to decimals, it also get the same answer as manual calculation. For the last part for question number 3 is 3D, need to calculate the particular solution for y1x and y2x with given value y0 equals to 1 over negative 1. Simulation shows here that y1 equals to c1 plus c2 minus 1 over 2. And here is y2 and equals to 0. Then I need to find the value for c1 and c2 first. The value for c1 and c2 is in fraction, but if change it to decimal, the answer also same as manual calculation. Then I need to substitute the c1 and c2 value with I, which is the general solution equation that we got from question 3C. Then I get the value in simulation, but a bit different with manual calculation. But the difference between these two, just a few points. So the answer is acceptable. Then I got the overall equation for this part.
Hello, my name is Luis. I will explain about the question 4 of our view project. And question 4 have two parts. It's question 4A and question 4B. So question 4A divided into the two parts. Question 4A is about given a differential equation y double prime minus 8y prime plus 3y equal to ft, where ft is a periodic function as shown in this figure 4A here. And first one we need to find is the piecewise function of ft, and second one is we need to find the Laplace transform ys of the differential equation with initial values when t equals to 0, y equal to 1, and y prime equal to negative 2. So A, we need to find the piecewise function of ft of the y double prime minus y prime plus 3y equal to ft. Ft equal to g, ft equal to t less or equal to 1 or less than 1, t less than 1 or less than 2, 1. And the second one, we need to find the Laplace transform ys of the differential equation with the initial values when t equals to 0, y equal to 1, and y prime equal to negative 2. So we follow the step Ly double prime minus Ly plus Laplace 3y equal to Laplace ft equal to s squared ys minus s y0 y prime 0 minus sys plus at y0 plus 3ys equal to fs. And we follow the step y prime 0 equal to negative 2, y0 equal to 1, and do step by step, and we get the final answer is negative 10 plus s over s squared plus minus at s plus 3. So now we move on to B. A series RS circuit is shown in figure 4B, where R equal to 10 ohm and L equal to 2H. The source of the circuit is given as Vt equal to 2 exponent negative t equal to minus 1 h t minus 1. The first one, we need to use the Kirchhoff law to show that the circuit can be represented by the equation dit over dt plus vit minus equal to exponent negative key minus 1, hash key minus 1. So this one is the circuit, and the second one is the current. We need to determine the current for the circuit using a Laplace transform with the initial condition I0 equal to 0. So this one is the calculation for the B1. We will get the final answer is dit over dt plus bit p minus 1 hash t minus 1. And number 2 is we need to determine the current IT for the circuit using a Laplace transform with initial condition I0 equal to 0. So this one is the step Laplace IT plus y Laplace IT equal to L E Laplace ET. So this one is follow step by step. And then we will get the final answer IT equal to 1 over 5 minus E exponent ET minus 1 over 5 minus exponent minus negative t minus 1 ht minus 1 plus 1 over 5 minus exponent negative t minus 2 ht minus 2 1 over 5 minus exponent negative t negative 2 and so on. So this next I will explain about the software that we use. For A1, we use the Siemens Mapper, and then we put in the equation, it will come up a graph like this. So show that the equation is the true one. Under A2 is we use the method, and we enter all the coding here, and then we get the result s minus 10 over 2 s at minus s plus 3. This one is our answer. And for B1, we use the method. So we also put in the coding, and then we go get the answer. And for B2, we use the mapper, and we also get the coding, and we will get the answer like this. That's all for question 4.